Hi everyone, today we will look another part of chapter 8, measures of dispersion for ungrouped data. That is, advantages and disadvantages of various measures of dispersion. Measures of dispersion measure the distribution of a set of data. The range is the measure of dispersion easiest to calculate. However, the range cannot provide a good overview of how data is distributed. So range always easy to calculate, but it cannot provide a good overview of how data is distributed. In cases where there is an outlier or extreme value, that means a value that is differ a lot from the other values. The interquartile range will be the more appropriate measure of dispersion to show the distribution of the data. Standard deviation is usually used to compare two sets of data. In general, a low standard deviation indicates that the data is dispersed close to the mean, while a high standard deviation indicates that the data is dispersed far from the mean. So now we look some examples so you can understand better which measure of dispersion that can be used to compare two sets of data. Example 10. You can refer your textbook at page 224. Calculate the range and interquartile range of the set of data 10, 11, 11, 14, 18, 20, 21, 21, 25, and 40. Determine the most appropriate measure of dispersion to be used to measure the distribution of the data set. So before this, we already look how to find range. To find range is the highest value minus with the lowest. Okay, largest minus lowest. So from the data given, the largest value is 40 and the lowest value is 10. So 40 minus 10 is 30. Next, interquartile range. Interquartile range, the first step is we find the median. So from the given data, you have 5, 6, 7, 8, 9, 10. 10 values. So you divide into 2. So when you divide into 2, then for first quartile, you find the center value of the first part, that is 11. And for the second part, the center value is 21. So 21 will be your third quartile. Minus 11 will be the first quartile. So interquartile range is third quartile minus first quartile. 21 minus 11, that is 10. So here range is 30, interquartile range is 10. So how to determine the appropriate measure of dispersion? We look at the data given. Here we got 10, 11, then you got 14, 18, 20, 21, 25, and suddenly you have 40. 40 with the other values differ a lot. The difference between 40 and the other values are quite large. So interquartile range is the most appropriate measure of dispersion because the existence of the outlier 40. So 40, the value is the difference is quite high. That's why we name it as outlier. So because got outlier, interquartile range is the most appropriate measure of dispersion. Next, we look example 11, also at the same page. The table below shows the achievement of two pupils in 5 physics tests. So we have Aiman and John. The marks given for test 1, test 2, test 3, test 4 and test 5. So Aiman achieved 40 for test 1, 70 for test 2, 90 for test 3, 85 for test 4 and 64 for test 5. Whereas John achieved 80 for test 1, 65 for test 2, 73 for test 3, 58 for test 4 and 73 for test 5. One of the pupils will be selected to represent the school in a physics quiz competition. Determine who is eligible to be selected and justify your answer. So in this case, we want to identify which student has a consistent performance. So we want to compare the achievement of two pupils. So we have to calculate the standard deviation. So for Aiman, before we calculate standard deviation, remember we have to calculate the mean mark. So for Aiman, the mean mark, okay, we add all the marks 40 plus 70 plus 90 plus 85 plus 64 divide by 5. So we get mean mark is 69.8. Then standard deviation. Standard deviation, we find the square, sum of square first, that is 40 square plus 70 square plus 90 square plus 85 square plus 64 square over number of tests is 5 minus mean square. So standard deviation square root, you get 17.67. So Aiman, standard deviation for Aiman is 17.67. Next, we calculate for John. The mean mark is 80 plus 65 plus 75 plus 58 plus 73 divided by 5. So mean mark is 69.8. Then standard deviation. So standard deviation, we find the square, sum of square first. 80 square plus 65 square plus 73 square plus 58 square plus 73 square. Then you divide by 5. Then minus mean square. So the standard deviation for John is 7.574. So the standard deviation for John is less than Aiman. So if the standard deviation is lower, that means the achievement of the pupil is more consistent. So here, John will be selected to participate in the physics quiz competition. The standard deviation of John's score is lower because John's achievement is more consistent. I hope everyone understand the topic. Thanks for watching.